Hey ladies and gentlemen, Mr. Piercy here with our next lesson about angle pairs. In the previous video, you were introduced to the idea that when we have two lines that are crossed or cut, is the way geometry likes to say it, with a transversal line, then certain types of angle pairs are formed. The corresponding angles, alternate interior angles, alternate exterior angles, and either same side interior angles or consecutive interior angles, depending on maybe the publisher or the year. Consecutive interiors, same side interior angles, remember they're the same thing. Now in your notes, I know this diagram is not in them, but I would like you to copy the three lines that I have here. I have line A, B, and C, and they're all intersecting. Now each line, A, B, and C, fits the definition of what a transversal line is, which is simply a line that crosses two other lines in the same plane. So each of these lines can act as a transversal line. And what I would like you to do is to copy this diagram down into your notes and the four questions that I have. The first question, I'm asking you to identify corresponding angles to angle 1. The next one, I'm asking you to identify alternate interior angles with angle 8. The third one, I'm asking you to identify alternate exterior angles with angle 10. And in the last question, any same side or consecutive interior angles to angle 4. So copy the diagram down and answer these four questions in your notes. And when you're done, come back, push play, and see how you did. All right, so again, I have no choice but to assume that you are actually doing what I've asked you to do, and you have attempted to answer each of these four questions to the best of your ability. Looking at angle 1, we can identify a couple of different corresponding angles. So if I say line B is a transversal line, then I would be able to say that angle 5 is in a corresponding location as angle 1. Students commonly mistake angle 6 as a corresponding angle to angle 1. And I think it has to do more with how the angles look and less about where they're located. Angle 1 and angle 6 do look similar in their angle measurement, but they do not sit in corresponding locations along a transversal line. So angle 6 doesn't work. I could also look at line A as a transversal line, and we could also identify angle 12 as a corresponding angle to angle 1. And again, common mistakes that I've seen students try to do is they would like to name angle 11 as a corresponding angle to angle 1. So let's move on to the second question, alternate interior angles to angle 8. Now again, we have two lines that could act as transversal lines with angle 8. So an alternate interior angle to angle 8, if I use line B as a transversal line, would be angle 2. If I use line C as a transversal line, angle 10 would be an alternate interior angle to angle 8. So let's take a look at the next one. Alternate exterior angles with angle 10. Now, the only kind of line that I can use as a transversal line here, where angle 10 is actually considered exterior, meaning it's not in between my other two lines, is line A. Unfortunately, line C, if I use line C as a transversal line, angle 10 would be in the interior of line A and B. So we can't use line C as a transversal line for this question. So that leaves us only line A as a potential transversal line. And here we're only going to be able to identify one angle that would be considered alternate exterior with angle 10, and in this case, it would be angle 1. Because they are both exterior to lines B and C, and they are on different sides of the transversal line A. So the last example, the last question I asked you to try, same side interior angles with angle 4. Now angle 4, if I look at line A as a transversal line, then I can say angle 12 is a same side interior angle to angle 4. Now if I try to use line B as a transversal line, angle 4 is not interior at that moment anymore. If I look at line B as a transversal line, angle 4 is exterior to lines A and C. So this is the only answer that we could have for a same side interior angle with angle 4. So these are the only correct answers that we could have for the angles that I've asked you to identify. So if you're having a difficult time identifying them, please take a note of go back and look at your notes and see what are the definitions, where are they located. And if you're really having a hard time, of course, please let me know, ask for help. I'll be happy to try and explain it to you a different way. Now moving on to the actual notes that we have today. After we identified these special angle pairs, the next thing that's going to follow is like, well, are there any special attributes or special characteristics that they have? And it turns out, if my lines are parallel, if the lines that create these angle pairs are parallel to each other, then yes, there are quite a few attributes that we can apply to these angles. Now here, the first thing that we're seeing is something known as a corresponding angles postulate. Now remember, a postulate is something you can accept to be true without having somebody to explain why it's true. Personally, I'm not sure I would accept this one to be a postulate. I think somebody would have to explain this to me. Maybe I would be able to see a pattern and therefore write a conjecture, but as a postulate, something I can accept to be true, I'm not 100% sure, but I'll accept it for what it's worth because I didn't write the material. Here we are saying that if I have corresponding angles that are formed with parallel lines, then those angles will be congruent to each other. So how do we use that? Well, there's a lot of different ways that we could do that. But let's take a look at the example here. Now this one specifically is just thinking about, well, how could we use corresponding angles to figure some things out in a diagram? So here we have the measure of three angles is 125 degrees. Well, which ones are 125 degrees? Well, according to the corresponding angles postulate that we just saw, where the 125 degrees is located, an angle that is corresponding to it is angle 7. So I should be able to say, go away, Dot. Ah. I should be able to say that the measurement of angle 7 should also be 125 degrees. Well, looking at vertical angles, and let me pick a different color here for vertical angles. For vertical angles, remember, vertical angles are always congruent. So angle 1 is considered a vertical angle to the 125 degrees, so that also has to be one of our 125 degree angles. But now we can say that angle 1 and angle 5 have make their own corresponding angle pair. So angle 1 and angle 5 also are corresponding angles, therefore they must also be 125 degrees to each other based on the corresponding angles postulate. Now looking down here, it's essentially the same question. We have angle 7 to be 75 degrees, and it's asking us to tell what would be the measurement of angle 1, 3, and 5, and why. What are they and why? So go ahead and pause the video, And when you're ready, come on back and check your answers, see how you did. Okay, so I'm assuming you've written down your answer and you're ready to go see what we got. So here we go. I said that the measurement of angle 3 has to be 75 degrees by the corresponding angles postulate because it's corresponding to angle 7. Angle 5 also has to be 75 degrees because, well, it's a vertical angle to angle 7, so they have to be the same. And if angle 5 is 75 degrees, then angle 1 must also be 75 degrees because it corresponds to angle 1. Now, some of you may have said, well, couldn't I say that angle 1 is 75 degrees because it's a vertical angle to angle 3? And you are absolutely correct. Yes, you could have. I just did not do that because we're primarily thinking about looking at our angle pairs, corresponding angle pairs specifically in this case. So that's why I went that route for the explanation. But absolutely, you could have said angle 1 would be 75 degrees because it is a vertical angle pair with angle 3. Now, moving on. Here, they're changing to what I think they should have been in the first place. They're calling them theorems now. But they're saying what we're looking at here is that not only are the corresponding angle pairs congruent when the lines are parallel, but so are alternate interior angles and alternate exterior angles. Those are also congruent to each other. Now, we could go through the whole process of constructing angles or constructing parallel lines and measuring these angles and comparing them how they look. But let's just use a little bit of reasoning to see, well, what would they be? Well, let's just say that the measurement of angle 4 here in the first example is 100 degrees. Well, that means that this one here, the corresponding, its alternate interior angle would also be 100 degrees. Well, why? Well, if we accept that the corresponding if we accept the corresponding angles postulate to be true, well, the angle that is here, the angle that's vertical to angle 4, must also be 100 degrees. And therefore, angle 5 would be its corresponding angle pair, so it would also have to be congruent. Therefore, we can say that the alternate interior angles must also be congruent to each other. Well, we can look at the same thing here. In the next example, let's just suppose that angle 1 is 100 degrees. Well, why would angle 8 also have to be 100 degrees? Well, according to our reasoning skills, again, angle 1 and its vertical angle are congruent to each other. So if that angle corresponds to angle 8 and corresponding angles are congruent, then we can conclude that yes, the alternate exterior angles will also be the same. So what about the consecutive interior or same side interior angles? Why would those be the same? Well, let's look at it this way. Peeping with angle 5, let's keep our numbers simple. Let's say angle 5 is 100 degrees. Well, its corresponding angle here would also be 100 degrees. Well, that corresponding angle and angle 3 form a linear pair. And as we know, linear pairs must be supplementary. Therefore, angle 3 must be 80 degrees. And we can very clearly see that the sum of angle 5 and angle 3 would equal 180 degrees, which makes them supplementary. So there's lots of ways that we can explain these things. Here I'm using a little bit of deductive reasoning to explain why these angles have to be the way they are. But we could also very much use constructions where we measure the angle, where we can make the angles and actually measure them. So let's take a look and see how they're used. Now, every time that you're going to be applying this information to a problem like what you see here in example 2, there's a question that I want you to ask yourselves. I always want you to ask yourself, what type of angle pair is this? Because if you do not answer that question first, in my experience, students are going to just make assumptions and say, well, I think it's this. And without identifying the angle pairs correctly, I see students regularly write equations incorrectly. And they can do the math, the algebra, perfectly fine from that point on, but if they don't set the equation up correctly in the first place, based on the answer of what type of angle pair is this, then you're lost. So take a moment and just ask yourselves, what type of angle pairs are these? So here is a pretty typical question. Find the value of x. The lines are parallel, so lines R and S are parallel to each other. They're giving us that information with the diagrams, with the arrow that we have on those. So therefore, we can conclude that these alternate exterior angles must be congruent to each other. So I've identified the angle pair that I have first, and now I can say, well, based on the fact that my lines are parallel, these alternate exterior angles are going to be congruent to each other, and that is how I have to set up my equation. Then from here, the actual algebra rarely poses a challenge. Now we're going to just move the 4 over through addition, and then we'll divide both sides by 3 to solve for x. So the value of x in this case is 39. But I cannot tell you how many times I will see students write an equation based on not asking themselves, well, what information did they give me in the first place? So here in example 3, this is kind of a real world problem. Say that 5 times fast. This doesn't have to be applied necessarily to an airport, although it is pretty typical. You could see roads in a city designed this way also. You might see painting lines done something like this, where you make something parallel to something else. But anyway, we have a taxiway being constructed, and we know that the measurement of angle 2 has to be 98 degrees. Well, it's not. It doesn't have to be. It is. So what is the measurement of angle 1, and how do you know? Now, personally, I would like to think of that question in reverse order. Well, because again, I want to know, well, what type of angle pairs do I have? Well, looking at the location of where angle 1 and angle 2 are in the diagram, those are alternate interior angles. So because they're alternate interior angles, then I can conclude that those two angles have to be congruent to each other. So by the definition of congruent angles, angle 1 and angle 2 have the same measurement, which in this case is 98 degrees. Now moving on here, this is where we're pretty much at the end, but I want you guys to pause the video, answer these 2 questions yourselves, and I know here you guys don't have that there, but you have it on your paper, so it's easy to see. I just moved it here so I could look at it while we were talking about it in classes. But go ahead and pause the video and answer questions 2 and 3 here, and when you're done, come on back and see how you did. All right. So looking at this one here, this question I really like. Question number 2, I really like it. Because if you're doing what I've asked you to do, which is before you attempt to set up an equation and solve it, you have to ask yourself, what kind of angle pairs are these? Now, let's just go ahead and, I don't know, give a color here for these. Let's say this one is green, and let's say this one is red. I know it's not Christmas, but we use Christmas colors. Are those angles, what type of angle pair are they? Well, the green angle is in the interior region of my parallel lines, and the red angle is in the exterior region of my parallel lines. So they do not form any special angle pair at all. They are not alternate interior, they are not alternate exterior, they are not same side interior, they are nothing to each other. But what I see a lot of times in class students doing is they don't make that connection, and they say, well, they just think it looks like some kind of alternate angle pair, alternate interior, alternate exterior, And so they say, well, it has to be one of those, and both of those are congruent to each other. And they set up the equation wrong based on not identifying the angle pairs correctly. They don't form a special angle pair. But based on what we were looking at before, I can say that the red angle and its vertical angle must be congruent to each other because of the vertical angles congruence theorem. And now we can see, oh, hey, these are really going to be same side interior angles, and same side interior angles are supplementary to each other. So I say one angle plus the other angle equals 180, do the math, and we get x to be 45.5. So I hope you set those equations up, that equation up correctly. So now again, here, suppose in example 3, so here's a diagram from example 3. Let's say that angle 3 is a consecutive interior angle to angle 2. Well, just like what we saw a second ago, same side interior angles or consecutive interior angles have to be supplementary. So I can say the measurement of those two angles have to add up to be 180 degrees. Substitute the 98 in for angle 2, move it over through subtraction, and say that the measurement of angle 3 is 82 degrees. So that's pretty much it for this lesson. What we're really talking about is, again, reinforcing the idea, can you identify your angle pairs correctly? Because if you can, you stand a very good chance of being successful with this concept. And once you identify your angle pairs, how do you set up an equation based on the fact that these are parallel lines that we're working with now? So as always, guys, any questions that you have, any thoughts that you have that you just want to run by me that you're not sure about, as you're watching these lessons, make sure you write your questions down, write your thoughts down, so that way they don't escape you. And when you're ready, shoot me an email, leave me a comment in the comment section of our classroom. Talk to each other about it. See what you guys think and compare your own thoughts. But until next time, guys, thanks for watching, and take care.